So equipment reliability, pillar 3, this is concerned with the equipment and equipment reliability processes for which maintenance and reliability professional is accountable. We'll discuss briefly the business objectives and production processes, but mostly we're going to be talking specifically about determining reliability expectations, evaluating reliability, working to optimize reliability for new and existing equipment, as well as establishing and justifying equipment reliability plans. So what we're going to talk about today, first we're going to talk about where does equipment reliability fit in. Then we'll talk about the specifics. 3.1, the subsection of pillar 3, the first one is determining equipment reliability expectations. The second is evaluating equipment reliability and identifying improvement opportunities. The third is establishing strategic plans to assure reliability of existing equipment. And you guessed it, the fifth is establishing strategic plans to assure reliability of new equipment. And we'll talk briefly about justifying the cost of the selected plan for implementation and implementing plans to assure equipment reliability. Then review reliability of equipment and justifying reliability strategies. So the first, if you participated in the Pillar 1 discussion, you remember this slide. And in order for an organization to carry out its marketing strategy, manufacturing strategy, and operating plan, there has to be a reliable equipment and systems. So if you remember, just briefly, the marketing strategy is typically based on what is the competitive strategy that the organization is trying to accomplish. They'll think about target customers and the target products, target market share and pricing, and that determines what they anticipate product demand will be. That factors into the manufacturing strategy, and that manufacturing strategy is all about how do they allocate the production resources, how do they optimize asset capacity, improve process reliability, and rationalize unprofitable assets. That then gives us the production targets that feed the operating plan. And within the operating plan, we're concerned with availability, throughput, and quality, or what you might know as overall equipment effectiveness. We also look to increase capacity. We want to produce at the lowest cost per unit, and we want to minimize variability. So again, equipment reliability supports the manufacturing strategy and the operating plan elements. How about the last pillar, pillar 2 that we did? We talked about the processes, right? So understanding operating processes, having some background knowledge and ability in process improvement, change management, and in maintaining processes. I'm not going to go through each one of these X's, but I just throw this little chart up here to show that each one of the pillar 3 sub-elements is aligned with one or more of the pillar 2 processes. So equipment reliability supports pillar 2, the manufacturing process reliability. Now if we think about any particular asset or piece of equipment, it has an operating life cycle. There's planning, preliminary, and final design. There's fabrication, installation, and commissioning. We then operate, maintain, upgrade, performing shutdowns and turnarounds until the end of its serviceable life. So let's relate the subsections of pillar 3 to the asset life cycle. So determining equipment reliability expectations should start during the planning and preliminary design process, and it extends all the way to end of life because we should be reevaluating it periodically. 3.2 is evaluating equipment reliability and identifying improvement opportunities. That really should be starting once you've installed and commissioned the equipment. We should be looking at it throughout its entire life thereafter. Establishing a strategic plan to assure reliability of existing equipment. This is in place, if we already have equipment in the plant, this is not something that we're starting from scratch. We have to think about making sure that we have a good strategic plan for reliability of existing equipment. If none exists, we have to develop it. For establishing a strategic plan to assure reliability for new equipment, that needs to happen during the planning and preliminary and final design stage. So we want to get out of the gates starting off in the right foot. 3.5 is justifying the cost of selected plans for implementation. And that dovetails pretty well with the Pillar 1 business and management section. Now, at some point, at the end of the useful life of that equipment, we really don't have to continue to justify the cost for the implementation of that equipment reliability plan. And implementing selected plans to assure equipment reliability, that really starts with the installation and commissioning and runs throughout the serviceable life of the equipment, as does reviewing reliability of equipment and adjusting the reliability strategy. All throughout the operating life, the manufacturing plan, the operations plan, and identification of strengths, weaknesses, opportunities, and threats will require us to use methodologies and different technologies or tools to continuously improve. So when we're determining equipment reliability expectations, there's a few inputs. The first, of course, is the business goals, the marketing strategy, the manufacturing strategy and operating plan, but then also the plant processes. How are those systems going to be operated? The way that they're operated can have an impact on asset reliability or equipment reliability. We also have to be cognizant of the regulatory and code requirements. And of course, each piece of equipment has inherent design capabilities and all of the interconnecting components, the utilities and the piping systems that go between different pieces of equipment. All of these things have inherent design capabilities. So when we're trying to determine the reliability and availability, the first thing we do is we look at the system design. And the system design is looking at the site, the utilities, the facilities, the core product or service systems. We think about redundancy and we think about the support systems that have to maintain that system. Within that system design, we then select specific equipment. And the equipment we're selecting, we have to think about structural, mechanical, electrical control, measurement, information, mobile equipment, and components or parts. And then, of course, we have to procure, install, and commission. Remember that quality of materials and components and precision installation, confirming performance to spec, etc., are all ways that we're going to need to make sure that equipment reliability meets our expectations. So some requirements to meet business expectations. Reliability. So we have to make sure it fulfills its function under the operating context that it was designed for. Availability. It has to operate when it's called upon to operate. Maintainability. Can it be accessed to properly service and repair? And safety. We have to make sure it doesn't pose any injury risk to personnel. Some other considerations: equipment uptime and downtime evaluation. So we want to be tracking and reviewing things like the mean time between failure and mean time to repair. Equipment failure assessment. So we need to keep track of how, when, and why equipment failed over time. So using a failure recording and corrective action system, or a FRACIS, and developing proper coding within CMMS, as computerized maintenance management software, these can be helpful in failure assessment. Production utilization. So we should be reviewing production planning and the actual production schedules. We should be determining if the equipment is being called upon in line with, less than, or more than the production plan, and why that is. And a point that people often forget about are things like turnarounds and shutdowns. These are dedicated periods for major maintenance, upgrade, and improvements. to take equipment out that takes equipment out of service. We evaluate the quality. We should be evaluating the quality of turnarounds. You have to compare the planned work quantity, quality, and scheduled completion hours with actual. So when we're looking at equipment reliability expectations, we should be thinking in terms of reliability modeling, availability simulations, and outage scheduling. Now, I'm not going to go through each and every one of these things, but you can see that there is some redundancy between some of these aspects. But criticality analysis, for instance, we remember that's severity times consequences, but also detectability. So that may drive some of our maintenance plans. So things like reliability block diagrams and reliability modeling help us to identify where the weak points are in the design. FMEAs and RCM helps us to define whether we're going to be using condition monitoring or time-based or frequency-based, interval-based maintenance, run to failure, etc. We should also be thinking about the operating parameters using SCADA systems or the plant historians to be able to derive information from the data. And of course, budgeting, our budget versus actual cost tracking, all of these things help us to validate or make sure that our reliability plan is in good condition. Availability simulation, we want to make sure there's an accurate asset register for maintenance significant items. Are we making sure that we have the right maintenance plan for specific equipment that we require to have certain levels of reliability? And you see again, criticality analysis, FMEAs, RCMs, FRACIS, root cause analysis, mechanical integrity inspections and risk-based inspections, system integrity, safety integrity levels. All these things are important for looking at availability. And then outage scheduling. We should be cognizant of the list of regulatory requirements for shutdown. We should be compiling maintenance and repair and upgrade and related tasks that need to be bundled within that outage. Developing a work breakdown structure so that it's organized. Estimating the time and materials and which contractors and types of contractors that we're going to be using. Estimating the lead time for inspections and critical path materials. And execute the outage. We want to manage and track and improve and report. So now let's move on to evaluating equipment reliability and identifying improvement opportunities. Any equipment that's not meeting performance expectations may be analyzed by a variety of methods, things like defect elimination, root cause analysis, even Weibull analysis. Nominal design parameters and best demonstrated performance levels should be used to identify improvements. So just because a system was designed to perform at a particular level, we want to be able to know what's the best demonstrated performance, and we should be able to meet or match that and try to maintain that level as much as possible. Look to see if the requirements have been changed over time. Are requirements exceeding the inherent design capability of the equipment? That's sort of the other side of the nominal design parameters in the above, the previous bullet point. We don't want to be running equipment beyond its design capability. That puts too much stress on the equipment and makes it so that the equipment reliability is not likely to be high enough for us. Comprehensive analysis can define improvement opportunities for achieving equipment performance that meets expectation. So what's the process for identifying improvement opportunities? It's pretty basic. We want to prioritize equipment to best allocate resources. We want our important resources, our limited resources, to be applied towards the most important problems. We then assess the current condition and capabilities of the equipment and systems. We then review equipment operating and maintenance history, looking for failure identification, and then identify performance gaps and opportunities for improvement. We want to develop an action plan to address equipment reliability gaps. So some of the things that we look at with equipment reliability measures include things like downtime, scheduled downtime and unscheduled downtime, mean time between failures, mean time to repair, mean time between maintenance, mean downtime, mean time to failure. Other related measures and analysis techniques are things like OEE, where we're looking at availability, quality, and throughput. Maintenance costs, environmental health and safety measures, energy efficiency, criticality analysis, root cause analysis, and Weibull analysis. We can also do asset health assessments. That's basically where you're looking at different types of equipment and setting up criteria for what we can measure and how we can put a value on the current status of that asset. So now, establishing a strategic plan to assure reliability of existing equipment. So equipment that's already in the plant, we have hopefully properly developed maintenance and reliability plans, and those should consist of optimal tasks to meet reliability, availability, maintainability, and safety requirements. We also want to do that at the lowest sustainable cost and the lowest use of resources. A thorough understanding of maintenance strategies. So when we're developing equipment reliability strategies for existing equipment, we want to be able to use condition-based maintenance, interval-based maintenance, restoration and replacement, failure finding, autonomous maintenance, run to failure, and even redesign where appropriate. We have the achievement of goal. The achievement of equipment reliability goals requires that we use the use of appropriate analysis techniques and the development of the proper maintenance strategy and tactics. So a little thought process here about risk identification and risk management. Risk mitigation. So the whole idea for improving and assuring the reliability of existing equipment is we have to identify risks that would impede the reliability of those assets and then mitigate those risks. So risks can be related to equipment failures as well as issues with criticality, procedures, or inherent reliability based on the design of the equipment. Risk mitigation includes strategies, tactics, plans, and activities to eliminate or reduce those risks. So what are some of the tools that we can use? Criticality assessment, reliability-centered maintenance and failure modes, effects, and criticality analysis, precision maintenance, autonomous maintenance, failure finding tasks, servicing, restoration, and repair, parts and inventory management, and condition-based maintenance, root cause failure analysis. Some of the process-related things that we do are to determine the equipment criticality, identify existing equipment with high cost and low reliability, and then we want to apply the appropriate tools to initiate or improve equipment maintenance strategies. So what about if it's a new piece of equipment? Well, during the planning and design phase, we want to incorporate maintenance and reliability best practices for initial design criteria. We want to incorporate those best practices into the design criteria. During the contracting and procurement phase, we want to specify equipment that yields the lowest life cycle cost while meeting business needs. We should consider maintenance strategies and repair part support. We're also quantifying cost of downtime to understand the total life cycle cost and the total cost of ownership. During installation and commissioning, we should have acceptance criteria and tests that prove that equipment reliability criteria can be met. And during commissioning, we want to have tests that should prove that the reliability criteria have been met. And for equipment purchases and installations there with no maintenance, where no maintenance history exists, we should apply recommended maintenance reliability best practices to assure best reliability outcomes. But where we do have existing equipment, we should be applying the existing maintenance and repair best practices to assure the best reliability outcomes. So in addition to existing equipment tools that we went over just a few minutes ago, life cycle cost analysis is used for new equipment, value stream mapping, purchasing specifications, reliability requirements, ergonomic requirements, vendor qualifications, performance and validation specs, precision installation specs, commissioning and operating specs, and spare parts strategies. Key new equipment processes, we want to design for reliability, design for availability, design for maintainability, and design for safety. We also want to design for supportability, and we want to define equipment maintenance strategies. Now let's talk about justifying the costs of the selected plans for implementation. Cost justification is based upon identified and quantified benefits or values, costs, or resources, and possibly risks associated with a proposed equipment reliability plan. These are used for decision-making and performance measurement. The information package is presented in a business case in a format suitable to your enterprise, how its budget reporting and analysis is done. The business analysis is a useful tool for obtaining management approval and sustainment budgets for labor, parts, equipment, software, training, and contractor support as needed. This is often an overlooked aspect of justifying the costs for equipment reliability. If we prescribe to do online monitoring or to have a certain amount of spare parts in stores, those are costs that are going to be associated with those assets over their life. And if reliability, because we've defined the reliability strategy for that asset the way that we have, we need to be able to communicate back to senior management as to why we're able to retain that level of reliability. It's because of the strategy. So if they start cutting costs and taking elements out of the strategy, we need to be able to communicate that as well. So justifying the cost, we're always talking about cost, benefit, and risks. So some things to think about. Do you know what the value of 1% of OEE is? If we can improve 1% of OEE, how much does that save the company? Effects of not meeting customer needs. So what happens when a customer is dissatisfied? What does that cost in terms of revenues or profits? What are the energy costs for the equipment and systems that we have in place? Can those costs be reduced? And what's the value of that reduction? What's the total life cycle cost and annual cost of managing the equipment reliability strategy? What are the total maintenance costs? What's the cost of unreliability for equipment and systems? So wrapping up the total costs as associated to equipment reliability or availability. What's the hurdle rate, or what we called in Pillar 1, the minimum acceptable rate of return for projects or for equipment reliability improvement projects? Safety or environmental potential costs. And this is one of my favorites. What's the cost of doing nothing? So if you propose an equipment reliability strategy and it gets shot down, well, if we've not been able to recoup those costs, what's that value, either annually or over the life cycle of that asset? The cost of doing nothing often is pretty expensive, and it can be used to leverage and try to sway decision makers to not do nothing. So what are some of the tools we use? Equipment reliability metrics. We want to be able to demonstrate what's the reliability based on downtime, total downtime, scheduled downtime, and unscheduled downtime. We should be able to communicate things in terms of mean time between failure, mean time to repair, mean time between maintenance, and mean downtime. Maintenance and production loss metrics. What are the costs? What are the costs of idle labor, waste or materials, service calls, rework, and wrench time, particularly if there's overtime costs? And again, the value of 1% of OEE. What are the environmental health and safety costs? Have we gotten any, because of some equipment reliability problem, have we been fined? Have there been any sort of consent decrees or consent orders given against us? What are the costs? How many injuries, recordable incidents have there been per 200,000 hours? Is that number going up or down? And of course, energy efficiency. What are some of the processes that we can use to assure reliability of new equipment? Develop maintenance business plan. Prioritize costs as required to meet the business plan. Calculate financial metrics to justify the scheduled maintenance plans. And I recommend that you do that using net present value or annual value. Again, as per Pillar 1, we want to be able to explain our economic values in terms that our corporate finance people and others that are concerned with money can relate to. Financial metrics that are required to manage maintenance plans. We want to create and manage equipment maintenance plan budgets. We want to use Pareto charts for cost of lost production plus maintenance costs. And ideally, you would have both of those costs in one bar, but show them as different colors or different areas. Determine the cost difference of scheduled versus unscheduled repair work. Conventional wisdom is that run to failure or reactive maintenance is 2.5 to 10 times more expensive than planned and scheduled maintenance. In your plant, it might be significantly different than that, but you should be able to calculate those values. And I also recommend that you create spreadsheets so that you can do what-if assessments and analysis to justify adjustments to the equipment maintenance plans. On the implementation side, implementing selected plans to assure equipment reliability is really fairly simple. We want to be monitoring equipment condition to know whether those equipment reliability strategies are doing well. We want to measure equipment performance. We want to then analyze data, and we want to communicate results and recommendations. We also want to be taking appropriate action to achieve specified reliability requirements. So that basically means to be attentive and assertive when we notice that our reliability is falling off, either because we're not following the plan or because the plan, the equipment reliability plan, is not good enough. So we want to be able to take the appropriate action to achieve those specified reliability requirements. Supporting and managing implementation of equipment reliability, we want to do design for reliability. We want to have procurement and storage of parts. We want to operate within design capabilities. We want to use precision maintenance and repair techniques. And to that end, we want to make sure that our people are well trained and we provide them with all the tools and equipment that they need to be able to do a good precision job. Equipment condition and performance monitoring. Failure identification and prediction. Failure prevention strategies and tactics. And require standardized maintenance procedures. We want preventive and corrective work initiation, maintenance management processes, which is the topic of Pillar 5 that we'll be going over in 2 more sessions from now. We should be applying root cause failure analysis. And we should make sure we have all of the resources needed to implement the equipment reliability strategies. There may be a need for organizational change management techniques. So if we're shifting from, say, one set of standard maintenance procedures, or perhaps we were using multiple maintenance procedures and we're trying to get people to follow just one, there's some elements of organizational change management there. And as I said earlier, craft skills. We want to make sure that we're training people constantly to either acquire or retain their craft skills. If there's a complex task that's part of the equipment reliability strategy, but it's only carried out once a year, it's difficult to expect people to be proficient at it. So we want to make sure that we have all of the right training aids and capability to give them the capability to carry out that equipment reliability strategy. There's also the need for soft skills for communicating and presenting the equipment reliability story. So we have to make sure that we're giving people that tool as well. And then don't forget about the impacts that outages have on economics. So one of the things that I always liked to do when I was in charge of a facility is I would try to minimize the amount of things that we packed into an outage. Anything that we could do outside of an outage, we tried to get done outside of the outage, and to save the outage period, to only do the things that we couldn't do otherwise. Yeah, you could fill some things in around the critical path, but generally speaking, the less complicated you make an outage, the higher your ability is to meet the time and cost deadlines. So what are some of the specific tools that are used to execute and support implementation? Well, that depends somewhat on the complexity and the configuration and operating context that you're using. But generally speaking, there's work management processes, and again, that's Pillar 5. Computerized maintenance management systems. We also talked earlier about key performance indicators. We want to know how we're doing relative to those key performance indicators. There should be very detailed, informative job descriptions, and those job descriptions also help us to make sure that we have a good training program in place. We should be using condition monitoring, predictive maintenance, and so that requires tools, hardware, software, and training. And of course, now there's quite a lot going on with remote monitoring, being able to put vibration sensors on a piece of equipment and having it remotely monitored. Process control and monitoring systems. So making sure that we're being able to review how the system is operating, whether the parameters, the inputs and control systems and so forth are operating correctly, so that the equipment is able to deliver the reliability that we're asking of it. Equipment control and monitoring systems, making sure that the individual pieces of equipment are operating correctly or as to their design capabilities. And we talked about skills training and communication plans already. So the processes to consider: think about maintenance information gathering and leveraging. So the use of a CMMS and fracas system and enterprise asset management software suites. Those allow us to aggregate data. We can also use things like machine learning and predictive analytics to be able to gather and leverage information. Failure prediction and analysis processes. So condition monitoring is part of that, but there's also other techniques that we can use to monitor or analyze and determine whether our reliability strategy is paying dividends. Communicating processes among functions. So this is, again, one of those things that within an organization, there shouldn't be silos. We should be able to communicate across from maintenance to operations to supply or support. We want everybody to be on the same page. Hiring and skills development. Of course, we want to have the best skilled craftsmen and tradesmen in our facilities. So we should have good hiring policies, practices, and good skills development practices that are aligned with the equipment reliability objectives. Standardization of maintenance and repair planning and scheduling. So this again goes to Pillar 5, where we'll talk about work management processes, but there are a number of other processes that come into play. Individual procedures on how we do things. The more standardization we have, the easier it is to identify problems and to make improvements to how we do business. Standardization of maintenance and repair task procedures. Again, we want to push everything towards precision maintenance, do things smart, do things with precision to make sure that we're not putting defects into our equipment that can be avoided. In business process improvement or continuous improvement, we want to be able to identify gaps in how our processes are done so that we can remove waste from the system. So then review reliability of equipment and adjust the reliability strategy. Every reliability program should be assessed against established reliability goals and process expectations. Now, this is an important point that I want to make as well. We often design systems and specify equipment to go into those systems during the planning and preliminary and final design stage. But how often do we actually go back 3 to 5 years later and see whether our systems are really being able to comply with what the reliability vision was for that system or that piece of equipment when it was on the design table? Oftentimes we just accept the way it is. So where did we go wrong? Being able to go back to the design step, the design phase, and try to understand where we missed the boat when we're not meeting those expectations. So I just encourage you to go back and look at the original design and equipment reliability expectations versus what we actually got achieved, and do some root cause analysis and continuous improvement to identify where those gaps existed, why we didn't get the reliability that we expected out of that system. Document those and use those for feedback for the next project. Carefully selected maintenance and reliability key performance indicators provide insight into the effectiveness of the reliability strategy as it is applied. Analysis and comparison of KPI trends. Identify causes of deviation from expected performance. Define adjustments, which in turn impact the KPI results. Relevant industry best practices and related metrics guide continual improvement of the maintenance and reliability processes. So we want to the maximum extent possible, use codes to identify failure modes by equipment class. We want to review and evaluate equipment maintenance plan performance. And we want to define corrective action processes and procedures. Again, the more standardization that we can get in how we do business, the more likely it is that we're going to achieve the reliability excellence. So that's what we're going to talk about today. So just as a matter of review, what we talked about is where does equipment reliability fit? We talked about determining equipment reliability expectations, evaluating equipment reliability and identifying improvement opportunities, establishing strategic plans to assure reliability of existing equipment and of new equipment, and justifying the costs of selected plans for implementation, implementing selected plans to assure equipment reliability, and reviewing reliability of equipment and justifying reliability strategies. So precision maintenance is really about making sure that whatever maintenance function that we're doing, we're using the best practice. So things like properly tensioning belts on a pulley and belt system, making sure that we have precision alignment using laser alignment gear, accounting for thermal growth in the housings of the motor and the driven equipment, making sure that we're using good, clean lubricants that we're putting in, making sure that we're using things like ultrasound lube caddies to make sure we're adding just the proper amount of grease to bearings. Precision maintenance is making sure that we're doing everything precisely, doing everything with the best quality so that we do not induce defects. We're doing everything we can to keep defects out of the equipment that we're working on. And that's true whether we're doing an installation and commissioning, or whether that's during the life of the asset when we're trying to do maintenance, repair, or any other procedure around that piece of equipment. The question is, so if we're in the, for instance, the preliminary planning and preliminary design, final design, so some of the metrics you could use there would be things like if there's a installation, so we're selecting equipment to be put into a system design. Are we selecting equipment that is the capability of that equipment is going to be acceptable to the design of that system? Did the reliability that we were planning on, right? So there's, if you do reliability modeling, for instance, and you said, let's say there's 10 pieces of equipment in a system, and we allocated what we thought the reliability was of each of those components or pieces of equipment within that system. Did we later, once we're in the operate, maintain phase of the asset's life, are we accomplishing that level of reliability? So you could measure that as you're, from the design phase to the operate and maintain phase. For the fabricate, install, and commission phase, same sort of thing. Did we have precision installation specifications and commissioning specifications? Did we follow them? Were we able to achieve the level of alignment that was specified before the asset was put into operation? You could look at metrics like that. Can you read the question again, Jess, because I want to make sure I'm covering this correctly.
Yes, let me go back. Can you elaborate on what metrics can be used in the phases of the project cycles for the equipment, such as design, installation, commissioning, and operations?
Yeah. So when you think about metrics, there's all sorts of levels of metrics, right? There's also things like business metrics. Are we meeting the economic expectations? Are we meeting the EH&S expectations? So those are sort of high-level metrics, but down to the individual piece of equipment, are we hitting the reliability that we expected out of that asset? And that would be measured in things like downtime, both scheduled and unscheduled downtime. I know a lot of people have issues with the metric of mean time between failure, but depending on what you're using that metric for, it can be beneficial to use to be able to communicate to non-maintenance people what's the status of that asset. I'm kind of struggling here because it's a pretty broad subject. I'll try to respond to that one by email, trying to get a little bit more detail for them.
Thanks, Tom. Another question we have is, can you elaborate on how training and defect elimination would fit into the overall equipment reliability, and how to evaluate the effects of these actions?
Yeah, sure. Defect elimination to me is a great tool to use because what we're doing is we're encouraging the shop floor folks, whether they're maintenance or operations, to identify where there are problems, where there are defects getting into our system or into our equipment. And we're using, I always say when I do FMEAs or when I work with plant personnel, the people that put their hands on the equipment have PhDs on the equipment. You know, so if there's an engineer or somebody comes in and they're trying to run an FMEA or RCM project, making sure that you include the people, the operators and maintainers who put their hands on the equipment, you have to do that to get a good product. And so when we're running a defect elimination program, that's actually a really good way when we identify that there's a gap between the current equipment reliability and where we expect the reliability level to be. Those are the frontline people that can identify defects that can help you get a better handle on where the gaps are and what the solutions are. Yeah, so typically KPIs fall into, there's generally 4 categories on, say, if you do a little research on balanced scorecard. Balanced scorecard is really a set of KPIs. You can have others, but within the balanced scorecard, they usually talk about finance, operations, quality, and employee satisfaction. And so basically, if you look at those main categories, there are sub measures that could fit under each one of those that help you to roll those values up. But KPIs, basically, that's probably one of the more well-known set of KPIs. But within an operations or a maintenance department, you can have lower level KPIs. Basically, what you're trying to do is set targets as to what performance level you want to be at, and then you set up measures that allow you to collect that information that would give you that target that you're trying to achieve. Yeah, absolutely. Absolutely. You can use it on any system or any piece of equipment or any object that you're trying to manage. Life cycle costs, so things like the amount of spares that you want to keep, total life cycle costs, because remember, when you have materials that are in stores, if you're a private company, you're paying insurance and taxes on the value of that material. So you can use life cycle costing to look at pretty much anything, because you want to look at what are the cost drivers for whatever it is that you're contemplating, and looking at the total cost, including, remember I was emphasizing the cost of downtime and the cost of doing nothing. So we want to be able to make sure that we incorporate the cost of downtime into our life cycle costs. And then the cost of doing nothing is kind of the corollary, right? It's if we don't change, then these life cycle costs are not going to change either. Okay, so the cost of unreliability. When a piece of equipment goes down because it was not reliable, if it causes a loss of production, that cost of lost production is also part of the cost of unreliability. So things like if one piece of equipment fails and there's collateral damage to other pieces of equipment, those costs of collateral damage also are a cost of unreliability, right? So cost of unreliability is what are all the chain reactions and the downstream costs of a piece of equipment that failed, that was not reliable, right? So it could be, and so this could also include a partial loss of function, right? So let's say a pump was supposed to be pushing 150 gallons per minute of fluid, and it's only pushing 90 gallons per minute of fluid. That lower production rate, that could have, that could result in an output of a product or service or material that is lower than what it should be because the equipment is not reliable. So all of those things can be rolled up into the cost of unreliability. But the hurdle rate is the same thing as the minimum acceptable rate of return, MAR. And basically what that means is every company has a rate of return that if a project is going to return less than that rate of return, the project is not going to be approved. So in other words, every project that they're going to move forward with has to give a rate of return greater than that hurdle rate or that MAR. And so the things that go into that, there's a lot of things that go into it, but the main things are what else could the corporation invest in that would have a minimum rate of return, right? So they could invest in government bonds, for instance, and make a 2% rate of return. So if that's the only thing you considered, then your project would have to be greater than that 2% rate of return. However, there are other things that go into that as well. Those other things add up to the point where if the company has X amount of dollars available for investment, they want to go after the ones that have the highest rate of returns, obviously. But as you come down and those projects get lower and lower, it still has to get above that hurdle rate to be able to get approval. Okay, so there's the cost of staff time and the cost of doing the design and so forth. That all has a cost. So when the company is considering what's the overhead and the total cost for doing that project, a lot of that filters into that minimum acceptable rate of return. So where you think that, yeah, I could save the company $10,000, well, but if it costs you $9,000 to get $10,000 return, it's probably not going to pass muster. If it costs you, if you're going to return $1 million, but it's only going to cost you $9,000 to do it, the rate of return on that is huge. And so you have a much greater likelihood that that project is going to be approved. So it's a rate of return that the company or the entity needs to see in a project before that project will be approved. And this is why we want to make sure we're doing the economic analysis on our reliability strategies for equipment to make sure that those strategies are going to give us a rate of return.